In this video, we're going to review the line, both the equation of a line as well as how that is interpreted graphically. So first off, the standard equation of a line is y equals m times x minus a plus b, where m is our slope. In other words, how much you have to move in the y direction divided by how much you have to move in the x direction to get to any point. And we know that the point A, B is on the line. So if I'm at the point A, B on a graph, so let's just in general draw some kind of graph, and here's the point that's on it, then to get to another point, I simply move delta x units in the left or right direction, and then go up delta y units in the y direction, and then I know that this right here has to be another point on my line. And in fact, any point on the line connecting these 2 points will adhere to this ratio. And so the minute I have a point, AB, and I have the slope, delta y over delta x, I can use that as a means to get to any other point on the line. So let's look at this at a very simple example. Consider the equation y equals x. Now this is of the form y equals m times x minus a plus b. In this case we have a and b both 0. So we know that the origin is a spot on the line. To get any new spot, we have that m is the coefficient out here, which is 1. And so our change in y divided by our change in x is 1, or solving this, I have that the change in y is identical to the change in x. So starting at 0, 0, this says if I move in the x direction any amount, say I move 1 unit in the x direction, so I get to here, then I would have to go 1 unit in the y direction to get to another point. So that would be a point on the line. Or say I want to go negative, so that would be to the left, 2 units in the x direction. Well, since delta y is equal to delta x, I would have to go negative 2 units in the y direction to get to a point. And so we see that that these are all points, and I could have gone negative 1 over and 1 down, giving me that, or I could have gone 1/2 over and half down, or half over and half up. And as long as x, the change in x and the change in y are the same, then these are points on the line. And of course we know that we could just connect the dots, giving ourselves what the line has to look like. Right? So there we go. We have the most simplest example, y equals x, in which the origin, 0, 0, is a point on the line, and the slope gives the ability, the direction, to get to any other point. Okay, so let's remove that equation and try another one. Say y equals, 1/2 x. So again, we have that a and b are both 0, and our slope in this case is 1 over 2. Right? That's our change in y divided by the change in x. Or solving for delta y, we see that the change in y will always be 1/2 the change in x. So again, like before, we have a starting point, say the origin. And if I want to get to a new spot on the graph, I can choose any delta x, and the change in y is dependent upon that change in x. So if I go, say 1 unit over, right? So if I go 1 unit over in the x direction, so my change in x is 1, then my change in y would be 1/2 times 1. So if delta x is 1, then change in y would be 1/2. So I have to go up half a unit. Well, here's 1/2 unit would be right here, right? That's 1/2. Or if instead I wanted to go, say, 2 units to the left in the x direction, so if I went there, -2 units, so delta x, in this case, delta x is equal to -2, then delta y would be, well, 1/2 times -2, which is -1. So I go down 1 unit in the y direction. So this would be another point on the line. And of course, I go through the same process and pick all sorts of points. If I go, say, 1/2 unit in the positive x direction, then I would go 1/2 times 1/2, so 1/4 unit in the y direction. Or if I went -1 in the x direction, I would go -1/2 in the y direction. And so we know these are all points on the line, and so I can just connect the dots and see, oh, well, there's what the graph of my line has to look like, something connecting these points, right? Sorry about the nasty line, but there we go. There would be our line. So slope is, again, just giving us direction if I'm at one point, how to get to another point. All right, let's clear this and try another example. Now let's say that y is equal to, say, 3 times x plus 1. And then, like we did before, now we have an a value. So a, if you recall, would be -1, because the general equation is y equals m times x minus a plus b. Right? So our a, since this is subtraction and we want addition, a would have to be -1. We have no b, so b is 0, and our slope, m, is 3. Again, what is that? That's the change in y over change in x, which tells us that the change in y is simply 3 times the change in x. So I know that the point -1, 0 is on the graph, so I know here is a spot on the graph, -1, 0, and this information tells me that however many units in the x direction I go, I have to go 3 times that in the y direction. So if x is 1, if I go 1 in this direction, then I will have to go 3, which is actually almost off my graph, but I have to go 1, 2, 3 units in the y direction. So if delta x is 1, this tells me that delta y is 3. Or if delta x is 1/2, then delta y is 3 times that, so it'd be 3/2. So if I go maybe 1/2 in the x direction, I will go 3/2. So I will go 1 and a half, right? That would be right there, 3 halves in the x direction. So I know that this is another point on my graph. So if I go, say, -1/2 in the x direction, then my y will change by -3 halves. So if I go 1/2 unit this way, in the negative direction, -1/2, then I will have to go 1.5, 3 halves, in the negative direction. And so again, I've got multiple points. So here's a point on the graph, here's a point on the graph, right? That's our starting point. Here's another one, and of course I could simply just connect the dots and get the semblance of what the line must look like, right? This just goes on in that direction.